Alright, Unit 4, here we go. First question, this is our log unit. We're going to go ahead and rewrite this as an exponent. So if I'm rewriting it as an exponent, I got to think of the base of the exponent. If it's a base 8 logarithm, it's a base 8 exponent. So 8 to the third equals 512. That's all you got to do when you rewrite it. Sketch the graph. If we have 2 to the x minus 3, now you have a graphing calculator, but we did this without a calculator. Let's see, just as a refresher. I'm going to make a table for 2 to the x. So 2 to the negative 1 is 1/2, and then these are powers of 2. And now if I want to graph 2 to the x plus 3, you got to remember that when you do a plus 3 inside the parentheses, that's going to make it go right 3. So that's going to change all my x values. I'm going to add 3 to these, so 2, 3, 4, 5, 6. And my y values didn't go up or down, so they stay the same. 2, 4, that's an 8. 2 to the third is 8. So this is my f of x. Now I can draw that. 2 is at 1/2, 3 is at 1, 4 is at 2, 5 is at 4, 6 is at 8, and you can see that this is going to get steep. That should be like right there. It's going to get steep in a hurry, and then it does have a horizontal asymptote that has not been moved up or down, so it's still horizontal asymptote at y equals 0. Again, you have a graphing calculator to help you, but if it's just a matter of moving it right, I can do that without it. Expressed in logarithmic form, so a base e exponent is going to be the natural log. So the natural log of 0.5 is x plus 1. If you're not sure about that, some people I've seen will do something like this, just to kind of make sure that they got it. E to the x plus 1 equals 0.5. Alright, cool. Now you should never write actually base log e, but if it helps you just to kind of make sense of things, it's not a bad trick. Use the laws of logarithm to condense. So right now, first thing I'm going to do is put these exponents back inside the logarithm. So that's x to the fourth minus log x squared plus 1. So to the 1/3 power. That's actually a cube root. I'll probably rewrite that. Log x minus 1 squared. Now that I've got the exponents in, I can start condensing, and we're going to condense left to right. So this is a subtraction. We're going to condense that into into division. And I'm going to write it as a cube root now. X squared plus 1. So I condensed the first two, and I'll leave this guy alone for a sec. X minus 1 squared. Now I have addition, and addition condenses into multiplication. So this is going to be x to the fourth, and then x minus 1 squared. That's in the numerator. And then in the denominator I have x squared plus 1. So that's my condensed logarithm. It ain't pretty, but it's only one log now. Use the law of logarithms to expand. So I'm basically going the other way now. I'm going to first get rid of this division, so a squared, and then it's going to be minus log of b to the fourth radical c. So I can take care of this one. This is going to be 2 times the log of a. And then over here, I'm going to break this guy up. This is log of b to the fourth plus log of the square root of c. And the trick to this is when you have this minus sign, you got to make sure that that minus sign gets distributed. So we'll come back to that. But you got to make sure that when you have a quantity here that's in the denominator, it's going to have to distribute the negative. So it'll be minus, and I'll bring the exponent out, 4 log b, and then minus, that's to the 1/2, so 1/2 log c. So now that I have all my exponents out and I've got this thing expanded, I am completely done. Let's see, what else? Given interest rate. Alright, so we can compound interest continuously, or we can do it via periods, and here we're doing it both ways to kind of figure out which way is going to give me more money. So if it says compounded semi-annually, that's twice a year, so we're starting with $1,000. 1 plus our interest rate is 0.0925, and if it's semi-annually, we're doing it twice. 8 years, semi-annually, we're going to compound interest 16 times. So if we do it like that, semi-annually, we're going to do $1,000, 1 plus 0.0925, missed 25 divided by 2, and that's going to the 16th power, and this will give me my balance, which is $2,061.42. $2,061.42. So I more than double my money. That's cool. What if I do it continuously? So continuously is the PE to the RT, so 1000 e to the 0.09, and for 8 years. So 1000 e to the 0.09 times 8. Which one gives me more money? 1000 e to the 0.09 times 8, and I'm going to get $2,054.43. So which one would you rather do? Well, even though it's continuously, which is generally better, it's a slightly lower rate, So that means if I had to pick, I take the 2061. That extra quarter point really does pay off. Solve the log. So when you have two logarithms, you got to condense it first. So this is now going to be log of x plus 2 times x minus 1. So addition condenses into multiplication. And now if it doesn't have a base, the base of the exponent is, or the base of the logarithm is 10. So this is called the common log, and it has a base 10. So 10 to the first is, if I expand that, it's going to be x squared minus x plus 2x plus 1x minus 2. Now I have a quadratic. I can get everything on one side. And now I can factor. So what multiplies to negative 12 and adds to 1? X plus 4, x minus 3. So x either equals negative 4 or x equals 3, but you got to be careful. It is possible that these are not in the domain. Negative 4, if you do negative 4 plus 2, you get negative 2, and you can't take the log of negative 2. You could take the log of 5, and you can take the log of 2, so this works. X equals 3 works. Negative 4 is extraneous. It's not in the domain. Evaluate the expressions. A lot of people will rewrite this as equations. 4 to the x equals 64, and you should just know that 4 to the third is 64. That's when you have memorized. This is, again, if it says 9, log base 9 of 9, if you rewrite it, 9 to the x equals 9, so you should be able to see that x equals 1. A base 9 logarithm cancels out an exponent. This is going to be 1. Let's see, 3 to the what is 1 over 27. What you have to realize here is that that is 3 cubed, and if it's in the denominator, it's negative 3, so then x equals negative 3. E to the natural log of radical 3. If you take a natural log as an exponent, and I have a base e, those are going to cancel each other out, and I'm just going to get radical 3. Same thing here, if it's a base 10 exponent and a base 10 logarithm, those cancel out, and you just get the argument of the logarithm up there, so 61. Last one, 25 to the x equals 125. When you have these numbers, if they're both powers of 5, you can rewrite it. This is 5 squared, and this is 5 cubed. And now you can see that if they have the same base, if I took the base 5 logarithm of both sides, I would get 2x equals 3, so x equals 3 halves. Solve the equation. Natural log is e, so this is e to the fourth equals x minus 1. So then if I solve for x, it's e to the fourth plus 1, and you just got to get that as a decimal. E to the fourth plus 1 to 6 decimal places is 55.598, 55.5981, and then what were the last two? 8150. So we got it. It's just a matter of getting the decimal. Evaluate the function. Here I just give you 2/3 to the x minus 1. I just plugged them in. 2/3 to the 1.3 minus 1. So this one's the 0.88. This guy is 0.078. This guy's 1.837. You're just plugging it in. Nothing fancy here. Just be careful with your order of operations that you close your parentheses for your exponents and you put the 2/3 in parentheses, and this is easy. Logarithm form, so here we have a base 8 exponent, so we need to write a base 8 logarithm, and it's 8 to the negative first. 8 to the negative first equals 1/8, so now we have it rewritten. Here we have a logarithm we need to solve, so I'm going to rewrite this as an exponent. 2 to the third equals 25 minus x. 2 to the third is 8. So if I subtract 8, I'm going to get 17, and I can add x, and I get x equals 17. And if I do 25 minus 17, I get 8, so 2 to the third is 8. Yep, that works. Expand again. First thing I'm going to do is bring out this 10, but again, you got to be careful. That 10 is actually x to the 10th, y to the 10th. So if I bring it out, I have to have parentheses. Now I have a base 2 log of multiplication expands into addition. So log 2x plus log 2y. You could leave it like that, or you might want to distribute 10 log x plus 10 log y. If it depends, it's multiple choice. It kind of depends on how they write their answer. Find x, so this is kind of like we just did. 4 to the x equals 2. Well, that's 2 squared. So if 2x equals 1, then x equals 1/2. X to the 3/2 equals 8. If you have x to the 3/2, in order to get rid of that 3/2 exponent, you're going to take the exponent 2/3 on both sides, because when you multiply exponents, or when you take a power to power, you multiply them, and when you multiply 3/2 times the reciprocal, you get just 1. On the right side, x to the 2/3, you do have a calculator, but this is saying take the third root of 8, which is 2, and then square it. So x equals 4. Last one, it is log of 0.1. If it doesn't tell you the base is implied to be 10. It's called the common log. So 10 to the x equals 0.1. 10 to the x equals 0.1 is 1/10, which is 10 to the negative first, so that means that x equals -1. Very last question for this whole review, solve the exponential equation. Easiest thing to do is take the base 3 log of both sides, because when you do that, you're going to end up with the base 3 log of a base 3 exponent. You can bring this out, and it's multiplied by 1, so those just cancel out. And now on the right side I have base 3 log of 5. This is some horrible decimal, so if I subtract 3, I have -3 plus the log 3 base of 5. When you type that in your calculator, some of you guys are aware there is a little hidden menu in here where you can do log base, but I'm going to just type it in using the change of base formula because I think it's faster. Log of 5 divided by log of 3. So if you're doing a log base 3 of 5, you can do change of base, log of the argument over log of the base, and when you type all that in, you get -1.535. X equals -1.535. It does say 6 decimals, so I'll get all 6. 026. 026. Now I got 6 decimal places, and I'm good to go. Ladies and gentlemen, that's it for our review. Good luck on your final exams.